Bismillah ar-Rahman ar-Rahim. Now we are going to discuss another fat-soluble vitamin, which is vitamin E. Vitamin E or tocopherols, or the antioxidant vitamin. The chemistry of vitamin E or tocopherols are characterized by the presence of tocool ring, to which is attached a polyisoprenoid side chain. Such polyisoprenoid side chain is the cause for the fat solubility and water insolubility of all fat soluble vitamins. It is present in vitamin A, now it is present in vitamin E, and we will see it again in vitamin K. We have many tocopherols. As a matter of fact, they are 8 in number. They are termed alpha, beta, gamma, delta tocopherols, etc. The difference between the different tocopherols is in the number of carbons and the structure of radical 1 and radical 2 groups attached to the tocool ring. Yani in here the differences between the alpha, beta, gamma and delta is the structure of the R groups attached to the tocool ring. So what's the sources? What are the sources of vitamin E? Vitamin E, the richest sources are the plant oils. Example, the vegetable oils as wheat germ oil, cottonseed oil, corn oil, and olive oil. It is present in the plant oils to protect such oils from auto-oxidation or from oxidation by the atmospheric oxygen. So vitamin E main sources or the richest sources are the vegetable oils present in the plants. Animal sources are poor sources of vitamin E, but it can be present in the liver, egg yolk, milk, and milk products. What are the functions of vitamin E? The main function of vitamin E is acting as antioxidant. Vitamin E prevents the peroxidation of the polyunsaturated fatty acids of the cell membrane. That's why we'll find hemolytic anemia in patients suffering from vitamin E. How vitamin E protects against the process of peroxidation is by acting as antioxidant, and it removes the deleterious effects of free radicals. The free radicals that can arise in our body can come from pollution, radiation, fried and burned foods, from the sunlight, or from combustion. We have a group of vitamins and enzymes that act as antioxidants. The beta carotenes are one of these. Provitamin A is an antioxidant. Vitamin C and vitamin E. These vitamins act as antioxidant. Glutathione peroxidase is an enzyme that protects against such free radicals. Selenium is an integral part of glutathione peroxidase. Another enzyme is the superoxide dismutase, or SOD, and such enzyme again acts as antioxidant, and it contains some trace metals like zinc, copper, iron, and manganese. The free radicals, if they arise inside our body, they will damage cells, causing cancer, artery damage, aging, and inflammation. So The danger of the free radicals is their destructive effect on the cell membranes and cell damage, causing different abnormalities and different diseases like cancers, atherosclerosis, aging, and accelerate the process of inflammation. The antioxidant activity of vitamin E is essential for number one, maintenance of the integrity of the RBC's membrane, protecting them against hemolysis. That's why one of the manifestations of vitamin E deficiency is hemolytic anemia and jaundice. Number two is increasing the efficiency of the immune system. So vitamin E acting as antioxidant will increase the efficiency of the immune system. Again, acting as antioxidant, vitamin E decrease the risk of development of myocardial infarction. How? Because vitamin E protects the LDL or low density lipoproteins from oxidation, and such oxidized LDL is the cause of atherosclerosis, the leading cause of myocardial infarction. Again, vitamin E, because it is antioxidant, it protects the liver cell from necrosis and lung cells from damage. Why these two specific organs? Because they are under the effect of oxygen and they are more liable for the production of peroxides, and such peroxides are the cause of free radicals that cause damage. Again, vitamin E is claimed to delay the process of aging due to its antioxidant activity. If we look to this figure, we'll notice that the free radicals, if they come to the cell membrane, it will cause its disruption and damage. How vitamin E protects against such free radicals? It donates an electron to the free radicals so they are stabilized. Now they neutralize the free radicals, which vitamin E causing their neutralization. Vitamin E will become minus an electron. It takes this, or it gets the lost electron from vitamin C. So vitamin C will give an electron to the vitamin E when vitamin E loses its electron in the process of protection against the free radicals. Vitamin E will become having less electron, and that can be reversible, and vitamin E can return back to the normal vitamin E, because vitamin E can be present in the oxidized form and in the reduced form, as we will see later on. What are the antioxidants? Antioxidants are compounds that protect cells from the damage caused by oxidation. What are the nutrients which act as antioxidants? We said that it is vitamin E, vitamin C, and it's a precursor of vitamin A, the beta carotenes. Selenium is a metal that protects against peroxidation and acts as antioxidant because it is an integral component of glutathione peroxidase. Now, vitamin E deficiency. What are the different causes that lead to vitamin E deficiency? Number one is severe malnutrition, as in cirrhosis of the liver. Cirrhosis produces bile salts, and the bile salts are important for the process of absorption of the fat-soluble vitamins, including vitamin E. Sometimes vitamin E deficiency may be due to genetic defects affecting alpha tocopherol transfer protein. Vitamin A, because it is fat soluble, it will not circulate in the blood as such. It needs transfer protein. If such transfer protein is defective, then vitamin E deficiency will result. Again, because vitamin E is a fat soluble vitamin, in case of fat malabsorption syndromes like in pancreatic insufficiency, celiac disease, regional enteritis, etc., vitamin E deficiency will occur. What are the manifestations of vitamin E deficiency? As we mentioned, the main manifestation of vitamin E deficiency is hemolytic anemia, as vitamin E acts as a protective antioxidant for the cell membrane from hemolysis. So the cell membrane of RBCs will rupture, resulting in hemolytic anemia and development of hemolytic jaundice. Again, another manifestation is muscle weakness. If there is any toxicity of vitamin E, the vitamin E toxicity is very rare. It is the least toxic of the fat soluble vitamins. But large doses, more than 1000 international units per day, may cause hemorrhage, because vitamin E in large doses acts as anticoagulant. So it is advised to stop vitamin E supplement 1 month before surgery. So vitamin E protects against hemolysis, but if taken in large doses, it will cause hemorrhage. It protects against hemolysis because it is antioxidant, and large doses will cause hemorrhage because vitamin E in large doses act as anticoagulant. Now the last vitamin of the fat soluble vitamins is vitamin K. It is termed naphthoquinones, or anti-hemorrhagic vitamin. Vitamin K is a derivative of naphthoquinone with long polyisoprenoid side chain. So this is naphthoquinone and this is polyisoprenoid side chain. It can be present in several forms. Vitamin K1, when the radical or this polyisoprenoid is containing 20 carbons. It is vitamin K2, it is of animal source. Vitamin K1 is of plant source, and the side chain or the polyisoprenoid side chain contains only 20 carbons. Vitamin K2 is of animal sources, and the radical contains 30 carbons. Vitamin K3 is a synthetic drug. It is termed menadione, and menadione has no hydrophobic polyisoprenoid side chain. So vitamin K3 or menadione is a water-soluble synthetic compound. Such menadione is very useful in patients having biliary obstruction or obstructive jaundice, as it does not require bile salts for absorption. What are the different sources of vitamin K? Vitamin K1, as I mentioned, present in green plants as cabbage, cauliflower, and spinach. Fruits are poor sources. Animal products contain little amounts of vitamin K1. Vitamin K2 synthesized in large intestine by intestinal bacterial flora. Therefore, deficiency of vitamin K is rare, but deficiency of vitamin K may be present in the newly born infants because their large intestine is sterile. No bacterial flora has not been present in their large intestine, so young infants may have vitamin K deficiency. And of course, they will not eat plants in their early life. Vitamin K3 is synthetic water soluble drug, therefore it is given, as I mentioned, for patients suffering from obstructive jaundice. What are the functions of vitamin K? This is very important. Vitamin K is essential for blood coagulation. Essential for what? Essential for what we call a post-translational modification of the vitamin K dependent coagulation factors. What is the meaning of that? What are the vitamin K dependent coagulation factors? These are factor 2, 7, 9, 10, protein C, and the protein S. All these coagulation factors and anticoagulation factors, because factor 2, 7, 9, and 10 are procoagulant coagulation factors, whereas protein C and the protein S are anticoagulant vitamin K dependent proteins. So both the procoagulant and the anticoagulant coagulation factors are dependent on vitamin K. How? Because vitamin K dependent carboxylase is an enzyme in the liver that adds a carboxyl carbon dioxide group to the gamma carbon of certain glutamic acid residues present in these coagulation factors. It is added on, this is alpha, this is beta, and this is gamma carbon of the glutamic acid radical, to which carbon dioxide is added. It causes gamma carboxylation of these glutamic acid residues present in such proteins, which are factor 2, 7, 9, 10, protein C, and the protein S, as I said before. So vitamin K is essential for such carboxylase to add carbon dioxide for the radical of glutamic acids of these coagulation factors. Such addition of carbon dioxide, we call it GLA residues. The glutamic acid now, it is termed GLA residues on the coagulation factors. GLA residues are quite important to bridge with calcium with the negative phospholipid membrane of the blood platelets and the initiation of the coagulation cascade. This figure shows that in the liver, vitamin K is quite essential for the synthesis of functional coagulation factors. These coagulation factors are synthesized, and the anticoagulation proteins like protein C, S, and Z all are synthesized in the liver, but they are not functioning unless they are carboxylated by the help of a vitamin K dependent carboxylase. Here are the polypeptide chain of the different clotting factors. This is the polypeptide chain, in which there is glutamic acid residue. The glutamic acid radical is having an alpha, beta, and the gamma. In the gamma, there is already a carboxyl group. This is glutamyl residue present in the polypeptide chain of the different clotting factors. Now, vitamin K is essential for a carboxylase carboxylase dependent on vitamin K. Such carboxylase will add carbon dioxide to the gamma carbon of the radical of glutamic acid, transforming it into GLA residue or gamma carboxyglutamic acid residue. Such gamma carboxylated glutamic acid residue or GLA residue bridges calcium with the negative surface of the phospholipid membrane of the blood platelets and concentrate the blood coagulation factors at the site of energy, so blood coagulation cascade will occur. Here is the coagulation factors. They are synthesized as such, and these are precursors because they cannot function. They will not function except after the addition of carbon dioxide by the help of vitamin K for the carboxylase present in the liver to transform the glutamic acid residues into gamma carboxy glutamic acid residues. The gamma carboxy glutamate present in such coagulation factors. These coagulation factors will circulate in the blood, and at the site of injury, the calcium will bridge the coagulation factors with the negative phospholipid surfaces, and the process of coagulation will start. In the process of gamma carboxylation, vitamin K, which is hydroquinone, participate in the reaction for the vitamin K dependent carboxylase. In this reaction, vitamin K becomes oxidized into vitamin K epoxide, and the protein, which are the coagulation factors mentioned before, will become gamma carboxylated proteins. The vitamin K epoxide has to return back to the hydroquinone. This occurs by the help of two reduction processes, or vitamin K epoxide reductase, which needs hydrogen from lipoic acid. In such a reaction, the lipoic acid loses its hydrogen, becomes oxidized lipoic acid, and transformed into vitamin K. Again, the another reduction reaction, the vitamin K will be transformed into the hydroquinone by the help again of lipoic acid, which will lose two hydrogens to become oxidized lipoic acid, and again from hydrogen from reduced coenzyme 1 or coenzyme 2, reduced NADH or NADPH. They supply for the hydrogen for the process of reduction of vitamin K to the hydroquinone. The process of reduction of vitamin K epoxide or the vitamin K can be interrupted by means of warfarin. So warfarin will act as anticoagulant drug. Why? Because it prevents the reduction of the oxidized vitamin K, the epoxide form of vitamin K, back to the hydroquinone. So treatment of warfarin overdose, anticoagulant drug, and coumarin poisoning, rodenticide drug. So vitamin K can be used in the treatment of warfarin overdose or coumarin positive, because vitamin K, when it is given, it will overcome such inhibitory effects, and it will work in the synthesis of the gamma carboxylated coagulation factors. Deficiency of vitamin K is rare or unusual. Why? Because adequate amounts are produced by intestinal bacteria, as we mentioned, for supplying vitamin K2. So vitamin K2 is supplied by the intestinal bacteria, or in adults it can be supplied from the diet, from the plant, vitamin K1. But deficiency of vitamin K may occur in the following conditions: as in malabsorption, because it is a fat-soluble vitamin, requires bile salts. In obstructive jaundice and chronic pancreatitis, there is no bile salts for the absorption of the fat-soluble vitamins. Again, in prolonged therapy with anticoagulants such as dicumarol, as dicumarol prevents the process of reduction of vitamin K epoxide back to the hydroquinone. In newborn infants, why? Because the intestine is sterile, there is no microorganism or there is no bacteria, so vitamin K2 will not be synthesized, and newborn infants will not take plant sources, so the vitamin K deficiency will occur. Again, why in the newborn infants? Because of the absence of the liver stores. Liver still has no stores of vitamin K. In adults, vitamin K deficiency may result from prolonged use of antibiotics. Why? Due to decreased bacterial population in the intestine. What are the deficiency manifestations of vitamin K? Deficiency will lead to internal and external hemorrhage. That's to say mucosal bleeding, easy bruisability, splinter hemorrhages, melena splinter hemorrhages under the nails. Melena is the passage of blood with the stool. Hematuria is the passage of blood with the urine. What are the laboratory tests that may show up vitamin K deficiency? It is there will be prolongation of the prothrombin time and prolongation of the clotting time. If there is any toxicity of vitamin K, yes, if vitamin K administered for prolonged time and in large doses can cause hemolytic anemia and jaundice. In infants, due to toxic effects effects on the membrane of red blood cells. Brain damage may also be present. So vitamin K in large doses in young infants may cause hemolytic anemia and jaundice, hyperbilirubinemia. Why? Due to its toxic effects on the membrane of red blood cells. It may cause brain damage also for such young infants if they take vitamin K in large doses and for long time. Thank you.